And today, the first speaker of the day is Alexander Makarov. Let's invite him to the stage.
Okay,
hi,
good
Alex.
morning, everyone. Hi.
Hi, how are you?
Fine.
Okay, so you're the Y framework lead. Did I pronounce it that well?
Well, not the worst pronunciation. It's pronounced the Yi framework. The word is Chinese, so a bit hard to pronounce correctly.
Okay, great. Sorry, but as an Italian, it's a hard time for me to start spelling stranger names like that. So you worked there from a long time. You also are a representative of that inside the PHP fig, and that's where we cross path multiple times. So that's the first time that we can see face to face in reality. And well, let's see that you're basically a really experienced developer. I think you are around for since, I don't know, 10 years, maybe more.
More, 15.
Whoa, that's a lot. So your talk today is about security, so I think it will be a very interesting one, right?
Okay, I hope so.
Okay, so I don't know if you're ready. I can give you the stage and let's go into the topic.
All right, so the talk is about security, as it was announced already. And I'm going to go from basic principles to the very PHP specifics. My name is Alexander Makarov, and here is some leftover from the Russian version of the slides on the very top. It says about me, and as I said, I'm 15 years in IT, started with Java, then went to the stuff that we are all using, the PHP, JavaScript, etc., writing, speaking, and organizing a conference that's called PHP Russia. And also I'm a lead in the Yi framework team and consulting, and that's where I can say that I'm not a true security expert in the sense that I'm not dealing with the cryptography. I'm not really great into math, etc. But well, I know a thing or two about security. Since I did a code audit for many projects and saw the same issues again and again. And that's why this talk. So the basics. The basics in security are never trust data no matter what. Filter input and escape output. That's two very basic but very fundamental principles. So the input could be forms, files, HTTP headers such as the server HTTPX forwarded for. Well, in PHP it's in the server variables, but some of these prefixed by HTTP are actually headers, so easily modifiable. So that's user agent, that's input as well, and it could be more. It depends on what your application actually does. The output is browser, it's console, it's database. Yes, database is the output as well. Well, it can be considered so. And it could be more. Again, it depends on the application. So what are the problems? The problems are first, insufficient filtering, and second is run escaping. That's the majority of security issues. And what is filtering? Filtering is making sure data is valid. And when filtering, you should always prefer whitelisting. Input is invalid by default unless proven otherwise. If you're not really following this principle, you're in a big trouble. So the safe thing is to use filter var in the PHP. It's used like displayed on the screen. That's fine. They have pretty good out-of-the-box filters. And another alternative is to use libraries and frameworks which are reliable. Well, what about escaping? escaping is making special characters behave like normal characters, and usually that is done by prefixing with another special character. And the trouble here is that each output has very, very different escaping rules. Common threads connected with what was said are XSS, that's the first thing, and XSS is a script that is injected into the page and is executed in user's browser. Well, I saw it in most projects I've reviewed because XSS is really, really easy to actually allow to happen. So in the worst case, it looks like this. So someone just outputs something from the GET request, and that's immediately maybe executed. Well, it looks quite innocent. It says hello. That's nothing wrong, right? But not really. Instead of alerting, it can do things from your name, such as ask your friends for money. Well, why not? Make you say and post things. That is more interesting, and it may transfer your funds. Well, possible. And it can even send nasty stuff to police and get you in real trouble. And it is all limited to the creativity of the attacker. So the XSS can get real nasty. Two main types are first order, that is executed immediately, and the second order, stored XSS, that's executed later. The one that is executed immediately is actually exploited as giving a link to someone or posting it to a public place, and people are following, and then something is executed. If they are logged in, then it is executed by their name. Well, that's nasty, but the second order I think is more serious, because the XSS is stored in the database or somewhere, and every person who opens the rendered page of your application or something like that, he actually executes this XSS. And well, usually it does not alert, so no one notices before it's too late. Solution is to escape output. First, if you need just text, well, if you're outputting to HTML, that's easy to escape. That's HTML special chars that does exactly that. And don't forget the encoding. It should be UTF-8 because, well, the specific encodings from the past are better not to be used at all. And if you need HTML, you can sanitize it. And the proven library is HTML Purifier. It's a bit dated, but it's supported, and I think it's the best library available on the market so far. So there are alternatives, but this one is really battle tested, and it's even used from another languages. It's like people in the, well, at least it was used in the past, I've seen. So people in the Ruby on Rails community were executing PHP just to pass HTML through this HTML purifier. So that's quite good. And another thing about escaping is that you should not save escaped input to the database, because you may need to edit it. That's the first reason, and because data in your database could not be trusted. As I said, that could be outputted anywhere, and that's why the output should be escaped, not input. By the way, well, previously the Chromium developers, the Google team initially, and then the open source team, they had XSS filter built in the browser. So for some basic XSS vulnerabilities, the browser was not allowing to execute the code. But then different attack vectors were invited that were to overcome the limitations of the filter, and in the end the battle stopped because the Chromium developers actually removed the XSS filter altogether. And yeah, that's not really possible to dynamically avoid such a vulnerability without denying to execute anything useful. So XSS in the admin panel is not less dangerous. It is very, very common that people think that it's admin panel, everyone from the company is actually there. It's not a big issue if there's an XSS vulnerability. But the reality is that it's easy. It's very easy to get to the admin panel of the company, because in the big company there are people making the work, and these people are of a very, very different levels. And for some, well, low quality work, maybe easy work such as moderation or something like that, it's very easy to get the job. So attacker could actually be hired by the company to pass the interview, and then he's into the admin panel and he can do the XSS, and admin panel is used by the admin as well. So usually that may lead to leak of the credentials, and then, well, the attacker just leaves the company and it's all right, makes a pause in a few months or even a year, and then just uses the credentials. Okay, so the second vulnerability is CSRF. It's when the third-party website submits forms to your website on behalf of the user. That is a bit connected, but not the same. So as a result, it's again using the user as a puppet. Yeah. So the solution is to introduce the CSRF tokens and to use the secure channel. CSRF tokens are a special value that is generated randomly. It's unique, and when a form is displayed, this unique token is added to it. Then the same token is written to a storage that's usually a session. When the form is submitted, tokens are checked to match. If they don't, then it's a failure, then something went wrong, and likely that's not the user who is actually submitting the form. So there is one huge misunderstanding about CSRF tokens, that modern browsers actually allow to deal with it with the same origin policy, and that it doesn't matter if CSRF protection is in the framework. That's not true, because, well, the same origin policy is only about the XML HTTP requests, so it's about the AJAX calls, synchronous ones, and it doesn't really prevent sending requests, it prevents getting results. So the request is there, it's kind of blind attack, but it's still possible. And, well, another rule is do not use get to modify application state. That's quite an easy to overlook, because everyone is kind of too lazy to create a form for the logout action, and we usually use a single A tag with a link to logout, right? But that's not really correct, since at one of the huge community platform that is in the Russian language, recently they introduced English as well, that's called Haber, and someone posted this. So it was like AMG SRC logout, and the post went to the main page, and everyone who went to the website was immediately logged out, including admins who were not able to delete the post. So they had to contact the IT guys to actually get there to the server and fix it. So using request is the same, because it includes get, at least if it's configured by default in the PHP ini. Now to the more interesting stuff. That's about filtering input and escaping output as well, but that's a bit different. That's more serious. That's SQL injection. And it is executing arbitrary SQL on a project database. So if you see something like that, and I've actually seen that in 2021 quite recently, So that's something that takes the email and selects the user from with the email specified, right? We can actually pass not the email but something like this. So what it does is it stops the parameter, it closes the parameter and then does or1. Or1 makes the condition true and there is no ordering, so it just comes from the database as it was written. So what is written first? It's the first user, and usually that's admin user, right? So this way anyone could actually select the admin user that, well, he can actually log in as an admin user usually. And that is SQL injection. But you can get more creative, and with the knowledge of the database specifics and some other stuff, you can actually load contents of the file or evaluate the PHP code. So that's basically execute anything on the server. Well, if that is allowed in the database. Yeah. So some people may get creative and your database inputs are actually come from really unexpected places. It may be not the first order like I've displayed before, but something of the second order and even the third order that may come from a very, very different system that you may consider your own. So the solution is to escape queries, of course, and to do it properly. So manual escaping is not really good. First, there was add slashes. It's really a no-go. I don't know why it was actually used to escape stuff, but then someone invented MySQL escape string, but it was not good enough. So they invented MySQL real escape string, right? Well, it was real escaping, it worked to some degree, but then nope. It contained some vulnerabilities as well, and I think that if not the next thing, we would have the MySQL real escape string quite soon. So that's because, well, the escaping could be easily forgotten. The context could be wrong. So values, tables, columns. So these MySQL escape string and MySQL real escape string are for values. They are not for tables. They are not for columns. For tables and columns, there are different escape methods. So, well, escaping could be incomplete, and that was the case with the MySQL escape string and then MySQL real escape string. And, well, the solution is to use prepared statements. Originally, prepared statements were not for escaping values. They were for performance, for preparing a query once, so the database optimizer database thing that parses the query and converts it to the actual query that will be executed is done only once, and then you doing something in the cycle in the for each and binding value. Each time it's a new value, and then you now execute it. So that was what it was originally for, but the good thing is that the escaping really worked here. So there is actually nothing to escape. So the email here is bind value. So you cannot really pass and close the query, get out of the value. And what about the table and column names? It's, well, you should really use whitelist. There is no good way to actually escape table and column names. Database provides some, and that's maybe okay, but if you know your schema, and you really should since you're using the relational database, just write down allow tables and not allow anything else. That's the most secure way. Then other vulnerabilities include lack of upload validation. That's ability to upload and execute code that happens. Usually that's misconfiguration of the web server that allows executing files such as .php or something like that and does not validate. You should really validate MIME and resave images, but that could be tricky as well. I'll mention it a bit later. So the code injection. It is where you directly execute the code. Hopefully, no one has eval in their code base anymore, but that actually happened, and I've seen that in the admin panels that allowed to do the templates in the PHP and input that as in a form in the text area. So the solution is to avoid eval or at least use a whitelist if the code is composed. Yeah, so that's quite easy. So another thing is you should really run PHP with as less permissions as possible, and recently everyone started to use Docker and containers. Previously it was the FreeBSD and jail, but yeah, nowadays just use Docker and that should be actually fine. No one could get out of the container except some really edge cases. So I've seen sometimes the unsafe includes. Hopefully we have auto loading nowadays, and majority of the projects use that, but some projects still don't, and that's a big loss. But yeah, here if you want to include something dynamically, just again use whitelist. Another thing is clickjacking. That's not really PHP related, but it's a brilliant attack. It was used to trick Twitter users once, and actually even the Twitter admins, as far as I remember. So the thing is that that malicious web page actually is included as the iframe, and it covers the real page, and it has opacity 0. So user sees the target web page, and the malicious web page just draws some invisible buttons on top of it and then submits something. Well, it may overlay the login password form, and then you just enter the login and password in the attacker's page, and he gets the password. Then it may pass actually the password to the real website and do the redirect, and you'll be logged in. And to solve it, you really should disable embedding the website in the frame. Currently, you can send a header that xframe options or xframe options it's either deny or same origin, or you can do it the old way via the JavaScript. That's a bit safer because there are still old browsers in the corporates. So passwords. Passwords are a bit more tricky. What's the problem? Well, attacker could guess your password. It can be done by brute force, it can be done a bit faster by dictionary attack, and it can be done from the timing attack. The timing attack is the fact that different passwords are selected differently, and based on the length, the match happens with a different response time. And if based on the timing, he can actually guess if the next character is all right or it's a wrong character. That's quite similar to the people who break the big secure safes. And yeah, they hear to the click in and do the match eventually. So solution is to limit attempts, right? So 10 guesses from an IP per minute and a captcha may solve it, but not really. It's still a problem because it's easy to change IP and there are database leaks. Well, the database leaks are happening quite often recently, and that's a huge problem. So does it matter how to store a password? Yes, of course. So you should not know user password. So you should never ever store a password in a plain text. You should save a hash only. And the thing is that it should be the right hash. So MD5, SHA1, SHA256, and even SHA512 are no-go. These are quite good hashes, but they are for the very, very, very different situation. So even with the salt, these are no-go, because all these hashes are meant to be computed fast, and that's not what really needed when dealing with passwords. Brute forcing of 8-character password hashed as SHA256 takes, well, on a single GPU that was sold in 2011, that's only 3.5 days. And that's about 20 hours on the more recent GPU. Well, more recent, it's like 5 years ago, but still. So with some kind of up-to-date cards, that's a farm already. That's only 2.5 hours. That's not really much if you even if you are not attacking a certain person, but brute forcing the whole database. That may give you some cool things. So why is GPU? Well, the GPU were cheap before the mining was invented. So and because of the mining, there are many farms out there, and that's easily to do parallel stuff. Yeah, and these GPUs are, well, not really expensive, even with the mining considered. It's not easy to get these, but well, at least it was okay before. So what to do? Use at least bcrypt. Bcrypt is a different kind of hash. It is meant to be not so fast. So when you actually do a login and the website responds slowly, that means that likely it's implemented correctly. And if it responds like too fast, then it's, well, it may be that they're just storing plain text password or using a quite fast hash, and that's not really good. So bcrypt introduces a workload for both CPU and GPU, and it is very, very GPU unfriendly, because it requires a lot of memory access, and that spoils all the parallelism that you get from such a farm. So cost and password strength are really important in bcrypt, and the cost is key derivation function iterations. So that's 12 is a safe choice, and he uses 13 just in case. Yeah, and let's do some calculations. So with the cost 13, it's 28 hashes per second on a previously cool video card with a GPU Titan X that was top-notch one day. And that is 700 in 2015, and we get so much hashes a day. And 6-character lowercase letter only password takes that many combinations, and that all takes like 127 days to brute force a single password. That's too much. Probably no one will actually wait for such a long time. But because there are farms nowadays, it's 21 days with the 6 of such cards, and it already pretty much makes sense to attack a certain person with such an amount of spending. That's not really huge money for an attacker, because he will reuse that for not a single password, but many attacks. And if we'll add numbers to the 6-character password, it will be already 21 days, and the cost will be cost will be too much. Well, the GPUs are getting better and cheaper. Well, if we don't consider crypto mining, of course, because recently it got really incredible about the cost and how hard it is to get a good GPU. But the AMD from the 2016 gives you 14 bcrypt hashes with the cost 13, and the cost is way lower than the NVIDIA ones. So Prepared Attacker has way better hardware. As you know, for the crypto mining, the people are using the ASIC stuff. That is the hardware that is specifically tailored for computing hashes, and there are like hardware for cracking the passwords. So bcrypt gives you only time, and if you know hashes are leaked, you should fix leaked source. That's not easy, but it is possible. Usually that's, well, some admin leaking the database from a backup that is left on the S3 bucket or something else. Then invalidate hashes. And the thing here is that you should really invite users to change the password and explain that password should be changed everywhere. Not only on your service, but everywhere. Because, well, users are lazy and they do not really want to remember many things, and they use the same password everywhere, or at least the variations of the same password. So that's why when the database is leaked and you are actually used the service, you should really check what password was used and if the password is used elsewhere. So well, suggest strong passwords, but do not limit them, because if you limit the password, like impose the minimum length, then it would give attacker way more time for free. So he will not brute force the all the set that was limited, and if you'll not limit the password length, that it would give you more time to react. If you can get really plenty of time if you'll use Ergon 2. The Ergon 2 was actually introduced to PHP thanks to Scott Archizevsky. He's from if I remember correctly, the company is called Paragon Initiative, the security company, and he consulted. Well, not consulted, but reviewed the framework in the past, and he's pretty much capable of doing the really advanced stuff. Not like me. I'm just amateur compared to him. Okay, so again, these are not for passwords. That's MD5 SHA of the all variations. Then it's the different stuff, the key derivation function. That's not really about passwords. So please don't use that, and instead use what is appropriate. So Ergon preferably, or at least bcrypt or scrypt. Then another attack is sessions. Well, that's quite old, but I've seen it. I've seen it quite recently. So that's session fixation. Give user a known session ID, and then well, when he logs in and has a session, you can reuse it. And another thing is you can obtain user cookie with a remember me or with a session ID. So how it's done, it's like you're doing a link. It looks like the real link, but in reality it has PHP sets ID with some known value, and then you wait for some time and log in, and likely you'll log in as another user. That was used in the PHP-based chats all the time in the past, but nowadays they're a bit different. So the solution is quite simple. Well, use cookies only in PHP ini. That should be quite simple, but in reality it's a few settings. So that's this, and this. Yeah, configuration could be a bit tricky. And another thing is that you should regenerate session ID with session regenerate ID true after logging in, or changing permissions, or doing any really significant action. Well, that's true for banking applications and all the applications working with money, etc. So don't forget to check permissions. Yeah, it happens. So it happens for multiple reasons. it happens in a majority of the quite big social networks. At least it happened in the past. So the VK Russian social network that was initially a clone of the Facebook, but then went into another way. It was serving the private albums with the photos of the users, but it was serving it without checking permissions, because in order to check permissions, you have to execute some code, go to the database, etc. And they have used unique hashes that were not really known to the end users. But someone actually got with the algorithm on how these hashes are computed, and that was a disaster because the private content of the users actually went public. So yeah, hiding is not securing, so prefer denying everything than allowing what's needed to actually using steganography or just doing security via obscurity. Information leaks, that's a problem as well. So that could be debug mode. The debug mode is really helpful when it shows you trace on the error, etc. Then the debug mode exists in the major frameworks, in the PHP, in the C#, everywhere. And that's error pages, that API responses containing too much info, that's version control. By the way, if you're serving an application and that has a Git directory inside, then you may be in trouble because it could be traversed. Password leaks, yes, from the VCS and from files. Yeah, the passwords could be leaked. You should not really assume that the source code of your application should contain password. A fix, yes. There is a fix to safely store passwords, and that's HashiCorp Vault. Or you can use your VCS provider environment variables. These exist in the GitHub, these exist in the GitLab, and as far as I remember, that exists in the Bitbucket as well. So there is a git leaks GitHub action that may check your source code constantly, and if something is leaked, like the password that was hard-coded or some API credentials or tokens, it will just warn you. And the thing is that it's not really possible to remove a thing from a repository, so you should really change your password then. Another fix is two-factor authentication, and if your password is leaked, that's not really enough, because, well, you should have access to user's phone or something like the token, the hardware key to actually log in or do an action. There is a website, Have I Been Pwned, that may display which services you used are actually where databases were leaked, and that's a sign that you should really change your passwords from time to time. And well, another thing is limiting passwords lifetime, but Microsoft actually does not recommend that based on their practice, because users again are lazy. And instead of inventing a new password, they are adding 123 to the end of the existing password, and that's it. Just shut up. That's how it works. Okay, random numbers. That's another quite interesting topic. They are used for tokens, reset passcodes, generated passwords, UID, etc. And the problem is that these numbers could be guessable if the random source is not good enough. Again, that's used for tokens, reset passwords, generated passwords, etc. And that could be guessed, and that's a big issue. Solution is to use a safe random sources. What E2 uses is like PHP7 random bytes, then LibreSSL, then cryptgen random if it's a Windows, then dev random on FreeBSD, and dev random if it's not the FreeBSD but another Linux. And if nothing about is available, then you should really fail. You should not really try to fix things yourself and generate some random number somehow. So Hopefully, with the PHP 7, the random bytes is available, and if you're not really using a legacy code, then you should really go with what PHP provides. That's actually another thing that Scott Archizevsky provided to the PHP. So thank you, Scott. Be careful about libraries. So there are two popular libraries for random. It's mcrypt and that's OpenSSL. So mcrypt is not maintained for more than 10 years. So the extension is maintained for the PHP, but the library itself is not. And it has issues. And these issues are not really small. Okay, so the OpenSSL has issues as well. Always conduct tests and ensure that your random is really random. What about the server stack? So first of all, be up to date. Update your Linux, update your Nginx, PHP database, and your favorite framework. But beware of insecure dependencies. If you're using npm, then you're in trouble because it's not really possible to evaluate all these hundreds of megabytes of dependencies. But with the PHP, we are pretty lucky that these dependencies are way less in the amount, and you can actually go there and review these. Well, yeah, and dependencies with vulnerabilities sometimes are introduced on purpose. That happened multiple times in the npm infrastructure using the common names, and it happened in the PHP world as well, but there it's a bit harder because the vendor namespace is reserved if at least one package is created. Well, don't trust, check. At least if you have time. If you don't, try to stick to good libraries that are security reviewed, or at least the ones that have many users. So someone there should be into security, and maybe he checked or she checked the code. Denial of service. Well, really plan it in advance and rely on firewall. That possibly that should be hardware one, but it could get really complicated if you haven't encountered it before. That's a really bad surprise if you experience that. And often that's not just denial of service attack, but stray bots, and these could be eliminated with the fail to ban or Cloudflare firewall easily. But if you really experienced the denial of service attack, haven't experienced admin around, and yeah. And admins and support aren't ideal either. So I've seen multiple times wide open memcached and MongoDB ports. I've seen support that is behaving weird, like with a Windows support activated Windows without even checking who's calling. And another instance is Hetzner support. I believe they fixed the issue, but previously I was calling them because my server was too busy to even log into it. And I called them and said, well, reboot the server that is hosting the domain something. And they just said okay and went and rebooted the server. Then I thought, well, I may called another domain, and what would happen? They go and reboot another server, another project. Well, that happens. And give permissions to SSH to prod to anyone within the company. That's a really bad idea, but admins do that as well. Servers are in many data centers, but APIs are without password. That's another problem, because previously it was the local LAN, then scalability problems come, and you should move something to another server, and sometimes the security perimeter is forgotten. Well, insecure S3 buckets. I have actually seen that as well. So very important data such as backups were put into S3 buckets, and then these buckets were not really secured. The thing is that security is really a process. It can be achieved once and for all. So if you do a review with a security expert in a month or two, you could be vulnerable again. And you should really educate your team and have someone familiar with the security, at least with the security basics in the team, and use VCS and do code reviews all the time. That's the only way to make your application secure enough. Well, think about bug bounty, because I've seen in multiple instances that bug bounties were not really practiced, and well, the bug bounty is way cheaper than getting your database leaked, and that actually attracts security researchers, at least white hats, to actually report bugs and give you time to fix the issue. That's a really good thing. Absolute security is not really possible. So the thing is about making it costly enough so it's not really profitable for the attacker. The thing is that if your system is very secure, then people are vulnerable. They lose flash drives, they lose laptops, they lose phones, and a few years ago someone from the Apple lost the prototype phone. That was quite funny, and it was in the reviews in the next day. So they let strangers into the office. So one of my hobbies is getting into the office without passing the security procedures. So that's quite easy. You buy something like coffee. It should be in both hands, and you should really come to the door and pretend that you do not have a spare hand to open it, and someone will let you in because you're bringing coffee for your colleagues. You're a good guy, right? And there in the office, there are stickers. There are stickers on the screens, there are stickers on the keyboard, and there were multiple instances of such stickers went really bad. So that was Hawaii joke, and someone got the password from the alarm system and announced an airstrike on Hawaii. And then there was a French TV issue when they filmed their own studio, and there was a sticker on the screen, and someone just logged in, and well, that went bad. So plan in advance. What if attacker got access to the system X? What data should never be exposed? And if the data should never be exposed, do not store it. For example, if you are not convenient with the processing money and storing the credit card numbers, it's better to make this someone else's problem and just use the gate. Should admin take down the server in case of being compromised? That's a good question, and it should be written in the instructions, because if the admin don't know, he'll hesitate. He'll hesitate for too long, because taking down the server is losing money, and not taking down the server is allowing attacker to download the dump or do something else. What was exit? How? What's the harm? How to fix that? That's the questions that should be answered. And then, after the immediate threat is gone, explain to the team so they won't make such mistake again, or find a technical means to enforce it. That's even better. Never stop learning. Because the new things are always popping up. So the target blank is unsafe, the image magic is unsafe, SMS are really unsafe. The XML is unsafe as well, because, it's the same as XSS, but it's called XXE. And then, unserializer is unsafe. That's quite new thing, but it's exploited recently pretty often. And even the CPUs are unsafe, because, someone invented a way to hiddenly get the data from the server without even logging in. Well, never stop learning. Make it too expensive to crack. As I said, the key is that you cannot make it really secure, and you should really make it too expensive. then they will be easier target and you'll be quite safe. Stay safe. Yeah, and well, to stay safe again, you need to make it expensive. Reading list, it's OWASP, but be careful because some sections are wiki, so it may contain not really up-to-date information, etc. But there is a testing guide, and that's awesome. Then Martin Fowler wrote about security, and that's quite a good read. And then there is a security section in the PHP manual. No one reads these sections, but that's actually pretty good. Number of password combinations calculator, that's just for reference if you want to calculate how much time it will take to crack the password. Then there is a component called security that's standalone and could be used could be used with any framework that's not really tied to Yi, so go ahead and use it. And there is a good section of QA security at Stack Exchange. And that's it. That's questions time. And if you want to click the links, etc., I've shared the slides. And you, after the conference, you can just open the slides and check it again. Thank you.
Okay, so thank you, Alex, for this talk. You really went through a lot of stuff in security. You probably didn't miss anything.
So, well, I'm pretty sure I've missed many advanced things, but that's a different topic.
Yeah, sure. Well, we already have 2 questions from the chat. Roberto is asking, what about security tooling for SAST or DAST? I think it's static versus dynamic testing.
Oh, yeah. So if you can use the static analysis, that's the way to go. Because the static analysis gives less false positives, and that's actually a great thing. You can, and it usually runs quite fast, so you can get it to the continuous integration pipeline and be quite safe, at least code-wise. So many cases, such as the XSS, could be detected like that. And dynamic analysis, that's about false positives. So you should have a person around who actually evaluates if the result is actually false positive or a real threat.
Okay, so it basically requires additional work by the developer.
Yeah, usually it does.
Okay, sure. I think Psalm has something for static analysis in security-wise. I've seen that it has taint analysis. I don't know if you already tried it.
Well, I've tried some of the OWASP scanners. Then I've tried the security analysis that is built in with Psalm. But the issue is that every framework introduces its own patterns. So these analysis usually works for the plain PHP quite well. So it detects the SQL injections there, but it doesn't really work with the frameworks. So for the frameworks, you should really find the custom rules for this framework or write your own.
Oh, so that for the end user, for the end developer, do you think it would be a useful tool for you, for example, as a framework author?
Yeah, I think so. It will be extremely useful for any particular framework to have like the ready-to-use analysis tool that checks the security of the application.
Yeah, right. Okay, so we have another question. Steven is asking, from your experience, what would be the rate of developers that write their own security components versus using popular and up-to-date libraries? So how many do they really roll their own against how many rely on official libraries, let's say?
Well, the majority are relying on official libraries, and that's fine, because in order to really do your own cryptography and do it correctly without any mistakes and pass all the reviews, etc., you should be really into it. And usually that means you're not really developing the regular stuff, like the not automating any businesses, and you're really into security, and that's it. So that's a very different niche and very different rates, and the rates and the security are usually way higher than the regular development, but that requires a lot of knowledge.
Yeah, basically you're Scott, as you said before. Okay, one last question that got in last minute. How should we securely store things that shouldn't be stored, like, medical data, sensitive information, money, and stuff like that? So what tool you can use to avoid saving in plain text something that you need to recover in opposition to a password, let's say?
Oh, you mean the crypto, right?
Yeah, that's a possible way.
Well, you can use a crypto, and if that's a password, I've actually mentioned that in the slide. It was HashiCorp Vault, and it provides some. Well, it fills your environment with the variables. So there are many tools like that.
Yeah, no, but I think that the question was more about business information. So like let's say that your application needs to store sensitive data for the user, not for handling the infrastructure.
So there are multiple ways to do so. Usually all the databases have a cryptography model, and in this cryptography model you may have a unique key for each user. So it could be user's password you don't know, or it could be something else. But when you log in, you're getting a token and passing the token each time with the all the requests, and it decrypts all the time. So that may be a solution. But there are complications, of course, such as how to index something to search, then, etc., not exposing this data. But yeah, it's really possible.
I've done something like that recently, maybe 2 years ago. I've used a library still done by Scott, which is amazing in that regard. I think the name was Cipher Suite. Basically, it gives you that same functionality, so cryptography at the database level, but on PHP side. I needed to do cryptography on MongoDB, and I hadn't any functionality on the DB for doing that. And it also has the indexing. Basically, it uses a blind index, it says, to search the cryptographic value. So it gives you a partial hash that you can save alongside the data. And basically, it says that if you match the hash, you're nearly certain that you're getting the right result. So basically, you search for the blind index, then you get the data, you decode the data using a key that it's injected in your system. And you may have some false positive that you can filter out if you want. And that's secure enough to do this kind of stuff. I needed that
for
because
majority
I needed
of cases.
to store information after receiving a delete request for GDPR. So basically, I wasn't allowed to have plain text of that data, but I could index by the email of the user. So I cryptographed that. I used the blind index on the email. And if one of my users wanted to see the logs for that, he could search for the exact email, get the exact match, and get the data decoded on the fly. So even if my database got breached, it was unreadable. So I think it's one way to do it in PHP.
That's a good way to do it in PHP, but the database side cryptography is a bit more optimized performance.
Sure.
That's why.
But in fact, it was used to store logs for a long time. In the case of, my legal department wants to know what happened to that user, even if it required us to delete data. And so it's something like, cold storage, let's say. That's fine.
Okay, got it. Yeah, that's a good case.
Oh, Derek, it's reminding us in the chat that MongoDB added that feature later. So
great. That's essential for many applications, so that's understandable.
Yeah, nowadays with GDPR and all these problems with security, surely it is. Okay, so that's all for question. Thank you, Alex, for the talk on all the information, and we can see you later in the chat if you will, right?
All right. Thanks everyone for listening.
Thank you.